What's up guys, Brian here. Welcome back. Today I'm going to show you guys how to multiply fractions, and I'm also going to teach you guys a little trick to make simplifying them a little bit easier. The nice thing about multiplying fractions is that out of all the operations, it's probably the easiest. That's why we start out with multiplying fractions rather than adding and subtracting fractions. So our first step is going to be to combine into one fraction. Second step is going to be multiply across. Third step is going to be to simplify. So let's do an example real quick. So let's go ahead and use 1/3. We'll just do this nice easy example first, and 5/2. So first step is combine into one fraction. So we just put one line out here, and we're going to combine the numerators. So 1 times 5, and we're going to combine the denominators. So 3 times 2. Next step, step 2, multiply across. 1 times 5 is 5. 3 times 2 is 6. We don't need to do step 3 in this case because 5 and 6 don't simplify down any further. So that one's done. It was nice and easy. So let's go and do a little bit more complicated one. Let me erase this. So let's do 4/9 times 3/10. Alright, so first step, combine into one fraction. So we'll just do one single line there. 4 times 3, and 9 times 10. So next step, multiply across. 4 times 3 is 12. 9 times 10 is going to give us 90. So unfortunately, we do have a third step to this question. 12 divided by 90 is not the simplest form of the fraction. So to do that, we could use prime factorization, which we learned in the previous video on how to reduce fractions with prime factorization. I'll link that video down below in the description for you guys that might want to catch up on that. But for now, I'm going to go ahead and just jump to the reduced fraction. And that's going to be 2/15. Again, if you missed how to do the reducing of the fraction, go ahead and jump to the video I've linked in the description, and that'll teach you how to reduce that, no problem. So using the same example, I actually just want to take a quick second and show you guys a trick that you can actually reduce as you're going through the problem, rather than doing all your reducing at the very end. If that's what you prefer to do, that's totally fine. You can completely ignore this part. It's just a cool trick that I learned that makes reducing bigger fractions a lot easier. So we'll go ahead and just take a little side step here. And what we're going to do is use a method called cross-reducing, or it's also called, your teacher might call it dividing out the common factor. And so essentially what you're going to do, and it's a little bit tricky, I understand that, but once you learn it, it's amazing, I promise you. So what we're going to do is we're going to look at the numerator, and we're going to look at the denominator. And we're going to look for two numbers that have a common factor. So for example, 4 and 9, there's no number that can go into both of those numbers, right? But 4 and 10, they're both even numbers, right? So we can actually divide a 4 by 2 if we divide the 10 by 2 as well. So what I mean by that is we can say 4 divided by 2 is 2. 10 divided by 2 is 5, right? So if you look there, all we did was take a 2 out of there. Because if you did 2 times 5, you get back to 10. So we can do the same thing here for the 3 and the 9. So 3 and 9, what's a common factor that can go into both of those numbers? In this case, it's going to be 3. So it's not too hard. So 3 can go into 3 once. 3 divided by 3 is 1, right? 9 divided by 3 is 3. So all we do now is say, hey, 2 times 1. 2 times 1. And on the bottom, 3 times 5. 3 times 5. Now we're back to the same thing. Just multiply across, and you have 2 times 1 is 2. 3 times 5 is 15. So you see, now we got to the same answer, but instead of having to do all of our reducing at the end, we actually just saved ourselves a bunch of trouble and reduced as we went, which tends to be a little bit easier. So if that still doesn't make sense, we'll do one more example, and hopefully we'll clarify it up. All right, so let's do a little bit more difficult example now. We're going to go ahead and do 3/5 times 10 times 11/12. All right, so now we have three fractions. It's a little bit crazy. We're going to go ahead and multiply all three of these fractions together, but it's all the same. So we're going to go ahead and combine all these into one fraction. So you put your one single bar out through there. Right, your 3. Now the second one here, you notice it doesn't have a bottom part, it doesn't have a denominator, right? But don't worry, if you see a number and it doesn't have anything in the denominator, you can just write it over 1. That's what I always did, and it helped me kind of figure it out in my mind. So we're going to go across now, times 10, and the last number is 11. Same thing for the bottom, 5 times 1 times 12. 5 times 1 times 12. And now our next step, just to multiply them all across. So 3 times 10 times 11, and then the bottom is going to be 5 times 1 times 12. So on the top, 330, and on the bottom we have 60. So here, again, you're going to run into the problem that, hey, these can be reduced down further. It's not the simplest form of the fraction. So if we went to this point, we actually have to go and do the prime factorization. Since we're not going to go ahead and do that in this video, that just comes out to be 11/2. So this 330 divided by 60 actually reduces all the way down to 11 divided by 2. Now let's go ahead and actually do this using that trick I showed you, and we'll go ahead and get through this and show you'll get to the same exact answer. So let's erase this, and we're just going to start from this step here. So it's a little side trail, right? So all we're going to do is go through here and say, hey, what in this fraction can we go ahead and pull common factors out of? So 3 and 5, there's no common factor that you can put into each of those numbers, right? There's nothing you can divide into 3 and nothing you can divide into 5 that's going to be the same number, right? There's no common factor. But between 5 and 10 here, there is a common factor. In this case, it's 5. Because 5 divided by 5 is 1, and 10 divided by 5 is 2. So 5 can be divided into each of those numbers. So we'll just do that real quick. 5 divided by 5 is 1. 10 divided by 5 is 2. And we can also reduce the 3 and the 12. So this is where knowing your multiplication tables helps a little bit, because you can be a little bit quicker at it. So 3 and 12, the common factor between those two numbers is 3. So you can go ahead and say 3 divided by 3 is 1. 12 divided by 3 is going to give you 4. Now the reason that nothing happened to these two is this is just 1. This is an 11. There's no common factors that you can pull out that's beneficial. I mean, 1 is a common factor of everything, right? It doesn't matter. It doesn't help us. So now we just go across here. We say 1 times 2 times 11. 1 times 2 times 11 on the top of our fraction. And 1 times 1 times 4 on the bottom. So now you might actually notice we have one more thing we can do. We can actually reduce this a little bit further, because we actually have another common factor we can pull out of this fraction. So we have 2 and we have 4. 2 can go into 4, right? These are both even numbers, so they're divisible by 2. So 2 can go into 2 once. 2 can go into 4 twice, right? So now we just have 1 times 1 times 11. And we have 1 times 1 times 2. Times 2. Now we are almost done. We just got to multiply across. So we have 1 times 11, which is 11. 1 times 1 times 2, which is 2. Boom. So now rather than having 330 divided by 60 that we have to go sort through and do prime factorization for, we can actually jump straight down using more simple math to just get our final answer. With that said, that's all I got for you guys today, so hopefully that was a little bit helpful, and I know it's a little bit complicated as well, but with some effort on your part, you're going to be able to get through this. It's going to become easier and easier. If you like this video, give it a like. If you comment below, that's great too. And if you could subscribe, that'd be awesome. So thanks guys. See you next time.